Hello, and a warm welcome to all the audience of this course. Today we are discussing lecture 9, which is entitled SSB with wheel loads. SSB means simply supported beam, and wheel load means two loads which are in continuation with each other, like a scooter, a bike, or a bicycle. Okay, so we are going to deal with influence line diagrams connected with this kind of loading, and we will learn how to draw the influence line diagram for that. So let us proceed. Now, we are given this problem. Here is your question that there is a simply supported beam of span 10 meters, right? And it is subjected to moving vehicular load. A vehicle consists of two wheel loads, 10 kilonewton and 20 kilonewton. Okay. So here is the wheel load, 10 kilonewton and 20 kilonewton, spaced 2 meter apart. Okay. And using influence line diagram, find out maximum reaction at a support, maximum reaction at a support and corresponding wheel load positioning and corresponding wheel load positioning. Second question is maximum bending moment and maximum shear force at 4 meter. Maximum shear force and bending moment at a section 4 meter from either support. Okay, so this is your question. So to solve this problem, we have to use the concept of influence line diagrams. So first of all, I'll create some space here. This is your 10-meter beam. First of all, I'll draw the influence line diagram. So first of all, let us draw the influence line diagram for support reaction. Okay. So now your job is to, and another condition is also there, that any load can lead the other. Any load can lead the other. A two-wheeler like Activa, scooter or bike, the front wheel load is slightly lesser than the back wheel load. The back wheel load is generally more. So you can imagine this two-wheel load like sort of an Activa scooter where 10 kilonewton is the front wheel and 20 kilonewton is the back wheel. But we are solving it for the condition that any load can lead the other. So that means 20 kilonewton can also come in the front and 10 kilonewton can also go at the back. So either 10 kilonewton or 20 kilonewton can lead the other. For that condition, we have to find out maximum support reaction, maximum bending moment, and maximum shear force. To do that, first of all, we have drawn the ILD of RA. Okay, this is my end A, this is my end B. And now I am going to place the wheel load here. So I have two situations. Either I can place load like this, that 10 in the front and 20 at the back. This is my case 1, and case 2 would be that 20 kilonewton is in the front and 10 kilonewton is the back. Only these two cases are possible. From the point load ILD, we already know that to calculate maximum support reaction, I have to multiply point load by corresponding ordinate. Okay, so if I have to get the RA due to case 1, and this is my case 2. So in case 1, so for that I need the ordinate value. This ordinate value is 1 and this is 2. So this is 8. So I can calculate this height h as h by 8 equal to 1 by 10. So h comes out to be 0.8. RA will be calculated as 20 into 1 plus 10 into 0.8. There would be 28 kilonewton. Well, if I solve it for case 2, RA would be 10 into 1 plus 20 into 0.8. This will be 10 plus 16, 26 kilonewton. So which one is the bigger one? This 28 kilonewton is the bigger one, and we should report this one. That RA max equal to 28 kilonewton. And that is natural also because this is the bigger ordinate and 20 is the bigger number. So bigger number multiplied with the bigger ordinate definitely will have a greater value than the smaller load multiplied by the bigger ordinate and bigger load multiplied by a smaller ordinate. So both side big combination we have that bigger load multiplied by bigger ordinate. I will get the maximum reaction in case of 20 kilonewton being exactly above the ordinate x equal to 0. Ordinate at x is equal to 0, which is 1. Okay, so you can note it down and then we are going to run this one. Okay, better than rubbing, I'm going to make it small. Alright, so now we are going to do second part where we have to find out the maximum shear force and bending moment at a section C located 4 meter from either support. So for that one, I am going to rub this reaction part. So now let us draw the um, shear force influence line diagram at x equal to 4 meter. Here's my shear force ILD, and this value is 0.4 with a negative sign, and this is plus 0.6. Okay, I know this. Then I know that my V loads are here. Okay, so for maximum negative shear force, now the shear force will be divided into two parts: maximum negative shear force and maximum positive shear force. Shear force, I am going to place my load like this: 10 and 20. And if this is 2, so I can find out this distance h2. So I can say that h2 by 2 is equal to 0.4 by 4.1. So h2 comes out 0.2, which is minus 0.2. Okay, so I can calculate maximum negative shear force equal to minus of 20 into 0.4 plus 10 into 0.2. This comes 4 to the 8, 0 plus 10 to the 20, 20 and this 10 kilonewton with a negative sign. Now if I talk about maximum positive shear force, for maximum positive shear force I am going to place the load here at the back. So maximum positive shear force equal to 20 into 0.6 plus 10 into this distance I want to know. So let's say this distance is h3. So you can write here that h3 by, so this is 2, this is 4 actually, this is 4, and total is 10. So no, this is 2. Okay, so this is 4 and this is 2, 6, and the remaining is 4. So h3 by 4 equal to 0.6 by 6. h3 comes out 0.4. Maximum positive shear force. So this is 0.4. So it comes 20 into 0.6 plus 10 into 0.4 into 6 to the 12 and 20 plus 4 by 40. 16 kilonewton. Okay, maximum positive shear force is 16 kilonewton. All right. Maximum positive shear force you have found out and maximum negative shear force you have found out. And the third part is maximum bending moment at the same section. For maximum bending moment, you will have to draw the ILD of bending moment. It is like this. And this value is AB by L. That means 4 into 6 divided by 10 equal to 2.4 by L equal to 2.4. So to calculate the maximum bending moment, you will have two situations in front of you. Either you place 20 here and 10 here, and the second case is you place 20 here. Okay. So for both the cases, you can find out the value, and the bigger one you can report. Okay, naturally, depending on the geometry of the problem, we can clearly see that this side the ordinate will be bigger. And what is that bigger ordinate, that also we can find out. This is h4. So h4 divided by 2.4 equal to 4 by 6. 4 by 6. So h4 comes out to be 4 into 2.4 divided by 6. So 6 4s are 24. 1.6 meter. Okay. So this is 1.6. So now you can calculate maximum bending moment as 20 into 2.4 plus 10 into 1.6 equal to 12 to the 48 plus this is your BMX. Let's see. Okay, so this is how we find the uh, maximum shear force, maximum bending moment, or maximum support reaction due to wheel. Okay. Similarly, we can do one more problem on this. The question is a simply supported beam of span 12 meters of 12 meters represents a railway bridge girder is subjected to moving axle load. A train wagon consists of two wheel loads, 30 kilonewton and 20 kilonewton. So one is 30 kilonewton and one is 20 kilonewton. If in the exam it is not specified that which load is in the front, that is the higher load or the lower load, you can try for both one and find out for which arrangement you are getting the maximum value of stress functions. Consists of two wheel load, 30 kilonewton and 20 kilonewton, spread 3 meter apart. So this is 3 meters. Right, across the entire span of the beam. Using the influence line diagram, determine the maximum reaction at the left support. Calculate Ra max. Will clearly indicate the critical and indicate the load position and indicate critical load position. Okay, maximum shear force and maximum bending moment at the section which is located 5 meters from the left support. Okay, so total span is 12 meters. So they are telling us to find maximum shear force and bending moment at section C, which is located 5 meters from left support. Okay, to solve this problem, first of all, you draw the influence line diagram of all three. Here are a This is your RB, and this is your shear force. And bending moment we can draw later on. If that is the case, for maximum loading, I am going to place the bigger load at the bigger ordinate. So this will be 30, this will be 20. Similarly, in this case, I am going to place 30 in the front and 20 at the back, right? So if this is 3 meter, so the entire is 3 meters. So 12 minus 3 is 9. So H by 9 equal to 1 by 12. So H by 9 equal to 1 divided by 12. So H equal to 3 by 4. Similarly here, this is 3 in H dash. So you can note H dash by 9 equal to 1 divided by 12. H dash equal to 3 by 4. Same. So if you have to calculate RA max, RA max is nothing but 30 into 1 plus 20 into 3 by 4. Okay. So if you calculate this, it will come 4, 5 the 25, 3 the 15. So 45 kilonewton. Now if you calculate the maximum shear force, for calculating maximum shear force, you will have to place the loading in such a way that 30 kilonewton is here and 20 kilonewton is here, right? And similarly for maximum positive shear force, you will have to do maximum negative this side and maximum positive this side. But the question is, what are the ordinate values? This value and this value. To find out that, we will need the coordinate. So this one is minus 5 by 12 and this 7 by 12. Okay. So H equal to H divided by this distance is 3. Total is 5, so that is 2. So H by 2 equal to minus 5 by 12 divided by H divided by 2 equal to minus 5 by 12 divided by 5. H equal to minus 1 by 6. Okay. Similarly, if you find out H dash, so my H dash comes out to be H dash by 30 dash H dash divided by this distance is 3. So total is 12. H dash by 9. H dash by 9 equal to this part 1 divided by 12. So H dash comes out to be this. Okay. So now if you want to find out maximum negative shear force, so that will be equal to 30 into 5 by 12 plus 20 into 1 by 6. Entire thing is a minus sign. So if you calculate this, you will get your answer. This is 12, this is 40, this is 5, 3 is 15. 150. So if you see 150, 190 divided by 12. So you can calculate this, you will get maximum negative shear value. Okay. Similarly, for maximum positive shear, for maximum positive shear force, maximum positive shear force, for maximum positive shear force, you have 30 into 7 by 12 plus 20 into h dash already calculated 3 by 4. 21 divided by 12 is 15 Newton. So if you calculate this, you'll get your answer of maximum positive shear force, right? And if you have to do it for maximum bending moment, so let me rub this portion. So now let us draw the ILD for bending moment. It is this figure. It is AB by L equal to AB by 12. This is AB by 12, right? And for getting the maximum bending moment, I am going to place my beam in such a way that 30 is this side and 20 is this side. Okay, because there is a more gradual decrement in the slope. Therefore, at a given length of 3 meter, which is the spacing of the wheel load, I will get lesser decrement if I keep the 20 kilonewton in the front. But what would be that decrement? So I can do h by 3, uh, h by 4 equal to h by 4 equal to 35 by 12 into h by 4 equal to 35 by 12 divided by this length, which is equal to 7. Okay, if you solve this, h equal to 20 divided by 12. Okay, so this is 20 by 12. So my maximum bending moment will be equal to Vm max equal to 30 into AB by L. So 35 by 12. 30 into 35 by 12 plus 20 into 20 by 12. And here is your final answer. You can calculate. Thank you very much.